If you've ever played a video game called Kerbal Space Program, you are familiar with just how complicated, but also how satisfying and rewarding this game is, that you are building up an entire fleet of rockets and you are pursuing missions to explore the entire solar system, or the Kerbal version of the solar system. And it feels very realistic. And you wonder, like, could I be designing actual missions for NASA? And the answer is maybe. Now, my guest today is Rodrigo Schmitt. He is a PhD research assistant at the School of Aeronautics and Astronautics at Purdue University. And he has just come out with a recent paper about how Kerbal Space Program can serve as a framework for actual mission planning, although you require a few mods to make it more advanced and more realistic, but then you can actually export what you've built in Kerbal Space Program to the more realistic simulations that actual mission planners use when they are designing their missions. So it's a very fascinating look at how these skills, these video game skills that you are learning, actually have a practical application in space exploration. You're helping. All right, here's the interview with Rodrigo Schmitt. Rodrigo, I have told the story many times here on the channel that I have learned more in just a few months of playing Kerbal Space Program than I did in decades of being a space journalist. It's one thing to report on upper stages and orbits and insertion burns and all of that kind of stuff. And it's a completely other thing to design the rocket, launch it, control it, and actually understand how that all works. What's your gaming experience with this?
Yeah, so I could talk a lot about the different aspects of Kerbal Space Program that makes it special. But I think that one of my favorite things about the game is the fact that it makes you put yourself in the position of an administrator. So, like, you're an engineer too, so you have to design the rockets, and that is pretty cool. But something that I really like about the game is the fact that you have to manage all the funds across all the different things that are involved in a mission. And especially when you put some mods, I've been doing my research with realism overhaul and realistic progression one. All of these things, they just make all of the processes of rolling out a rocket, having to wait for the time for the rocket to be put out. And this is just something, like, so many aspects that make this so much more complex than just the engineering and the science. That just makes the game just phenomenal for us to think about from an engineering perspective. I think it makes it so much more realistic. And I could go hours and hours about the technical aspects, but yeah.
And how well do people who actually work at NASA and ESA and various space agencies, how deep has Kerbal Space Program sort of penetrated their consciousness? Do a lot of people play it or are familiar with it?
I think that it's very well known. Like, I've talked to engineers from NASA that said that Kerbal Space Program is something that is used kind of like a back of the napkin calculation kind of thing, just to make sure that the concepts make sense before anything is set out concretely and set in stone. So I can't speak for everyone, but I do think that most of them do have an idea what the game is about and have at least played it before once or twice.
And I guess, what led you to actually doing a paper to figure out what role simulation games like this could have in actual spaceflight?
So there is a heritage in my lab at Purdue University on using simulation games for mission design. So we focus on the big picture of things, which is system of systems. So when you have one system like a spacecraft, it's hard enough for you to analyze its components. But when you have multiple systems and a lander and a rocket and all of these different systems in a mission, things get a lot more complex and what's called emergent behavior occurs. So in my lab, people have been doing research with simulation games to kind of simulate from a high level how can the interaction between different systems actually affect the outcomes of different missions. So one of the most popular studies that they've done before was on game balance. So essentially, in a military scenario of player versus player, how can allocating different resources actually affect the game balance between two different players? And you can see how that can be useful in the long run as you run simulations and actually see different ways that this can affect the outcome of a certain scenario. So what I've been trying to do for the long term is using the simulation game as a way of understanding how all of these decisions, all of these inputs can actually affect the outcome of a space mission. So I've been using AI techniques to be able to detect how all the different inputs of a design or orbital parameters can actually affect the performance and the cost of a mission. And this paper that I just published on Acta Astronautica was a stepping stone to be able to design these things in a more realistic way using all the mods of KSP.
And I think about the different, even like say a human mission to the moon. If we think back to the Apollo era, you had this giant rocket, Saturn V, which launched, that broke up into various little pieces. You had the service module, the command module with the lunar lander go into orbit around the moon. And then you had the lander land on the moon, and then they came back up on the ascent module and then switched back to the service module, and they came back and then they re-entered in the command module. That's one architecture. But then the Chinese, for example, or I guess the Soviets, they were planning their N1 rocket, which is a different structure. And then the Chinese, they're planning two separate rockets. One's going to have the command, one's going to have the service. It's going to meet with the lunar lander in orbit around the moon. They're going to go down, come back. And then that's totally different from what's happening with Artemis, with the Space Launch System and Starship and the multiple refueling, and then potentially the lunar gateway. And so I guess like those are all those large systems, right? And so I think for a lot of people who are trying to figure out like what is the right architecture, it's got to be really hard for mission planners to even sort out how to approach it from this big picture.
Yeah, and there are so many different options that end up affecting it, because if you think about SpaceX, for example, they're proposing using Starship and a number of refueling in orbit to be able to go to Mars, and even for the lunar missions, right? But that is all tied down to the type of propulsion that they're using, because all of their architecture is based on the use of methane that can be produced in situ on Mars. So it ties down to the subsystem level of what you're choosing for the subsystem components of the rockets and the different systems that go into a mission. So when you think about the selection of lunar landers, that is also true, because Starship itself from SpaceX is the lander, while in other architectures from Artemis 1, Artemis 2, from NASA, they are proposing to use separate landers. And you can have so many different options. You can have a descent element and a separate ascent element, which was the case sort of the Apollo missions. So all of these different concepts of operations, selecting different systems, they become really complex really, really fast. So you need to have ways of assessing all of these options in a more streamlined process. And that's kind of the rationale behind the studies that I'm proposing. So being able to, instead of using a back of the napkin calculation, actually use a simulation and getting all this data from the game in the most realistic way possible can really help not only engineers and scientists, but also space enthusiasts to be able to get more information and contribute to this because, as I said, it's just so complex. There are so many options, and no one knows it all. There are always people who know a lot about specific things. So being able to put it all together and actually provide the tools that people can use to be able to contribute is something really important.
And I think recently with the Artemis mission, and even with NASA's plans for returning to the moon, they're seeing reusability as a big chunk of this. Instead of throwing away your lunar lander, can you have a way that the whole stack is reusable? You can refuel it at the lunar gateway or something like that, or a fuel depot, and then you can keep using it. Or that, I know I reported on people proposing like a ferry that would go from the lunar gateway to like low lunar orbit, and then you would have the lander detached. It would go down and come back up, meet with the ferry. Maybe the ferry would have already refueled. Like there's all these different, when you're starting to think about reusability, then there's a whole bunch of different variables that make your missions more complicated, but then you also don't have to throw stuff away. And so I can imagine that just multiplies the complexity of these even more.
Yeah, absolutely. And that's one of the most fascinating parts that I wanted to study is the on-orbit refueling and reusability aspects, because this is actually something that can really enable these operations in space. And we're starting to see this kind of thing in the last couple of decades with the reusable rockets. But if we really want to be able to go to space in our lifetimes and actually explore the moon, Mars, beyond, for most people to be able to actually get this opportunity and get more involved with space exploration, we need to make space exploration cheaper. And to be able to make it cheaper, we need to make systems reusable. Like, just think about using a car. If you could buy a car and just drive it somewhere and just drive it back, and then you can never use it again. Like, it just becomes so hard for the average person to be able to access all of this like state-of-the-art technology. So actually enabling on-orbit refueling and propellant production in space, those are the big challenges that are going to be necessary for us to see space exploration more ubiquitous in the near future.
So give me a sense then. So like how would you work with Kerbal Space Program in doing a mission?
Yeah, so one of the big things that Kerbal enables is for you to be able to design the systems and their subsystems, right? So you can put all the parts together and be able to design a lunar lander that can have a number of different propellants. Now, one of the nice things about all of the mods that the community created are the capability to create more fine-tuned details about these designs. So instead of just selecting a specific capsule or sending, or say like a fuel tank, you can actually change all of these lengths, all of the geometry of all of these parts in a very minute way, and the physics actually holds. So the density of the propellants is going to be based on literature. The propellants themselves scale with the size. So you're going to see that the mass of the propellant is actually very realistic. And one of the nice things about the mods too is that you can get all of that information using what's called an API. An API is basically a way of you to get the information from the game in real time and then input that in your code. So all of that information from the designs can be input into another simulation, and you can do something even more complex if you want. So what we've done in the study is, instead of using the orbital mechanics of Kerbal itself, we've actually inputted some of the design parameters and used that in more advanced astrodynamics models. So we use a three-body problem, many like what are called halo orbits, many different things that are more advanced and that the game doesn't necessarily allow, even though there are mods that are starting to do that, like
Well,
Principia.
that's what I'm wondering. Like, when do I get to play NASA's actual simulator for the astrodynamics? Like, why doesn't that exist as a game?
Yeah, it's just really complex, right? These games are limited in bandwidth, and a lot of this software is actually restricted as well. Because, like as you know, space and defense, they're very tightly related. So usually the companies, they have proprietary software that they use. So using games like KSP can actually enable enthusiasts and engineers all over the world to be able to contribute to science in the near future. And I think this is one of the exciting things that I'm trying to promote with this kind of study.
And I wonder, though, I mean, are there creative solutions to problems that people playing Kerbal Space Program have discovered that have real applications in actual missions?
Oh, I have no doubt at that. Yeah, absolutely. It's, as I said, it's just there are so many different things that you can do in simulating the systems in the game that it's just a matter of like people putting their hands on and it getting this game to do what they want. So one example is a few months ago, actually, a group of researchers from MIT studied on-orbit operations for automating docking and just controls in space. And they were using KSP as one of the algorithms and using AI on top of that. So optimizing these operations in space, optimizing the designs, being able to like just understand all the different design options and how these systems interact. All of these things, they can be enabled using KSP and especially the very rich mods that people created for it.
I wonder, when I think about some of the greatest players of this game, they've got thousands of hours into Kerbal Space Program trying to figure out how to get a human return mission from, what's it, Duna, the various versions, being able to go all the way out to Pluto and back, and it's very challenging, or the KSP version of Pluto anyway, and it feels like these people have probably a lot more knowledge in orbital mechanics, have just more hands-on experience in thinking about and designing missions and dealing with things going wrong and so on than often people who actually do this time and work. But they have a more, I guess, a more creative toolkit that allows them to quickly think about new ideas and simulate stuff and try out different ideas and see what other people have done and learn from their mistakes and so on. But then they're slightly, from a realism standpoint, it's a less realistic, less compute intensive simulation. And so it could be that they're coming up with solutions that actually wouldn't work in real life. I've seen plenty of people have single stage to orbit space planes that probably wouldn't work. Mm-hmm. Just because the propulsion, the specific impulse is just a little too high, or the aerodynamic coefficient is like a little under fully described. And I wonder how you can sort of clear that gap, because I'm guessing that I can sort of imagine these competitions where NASA goes like, we want to bring humans back from Titan. Here's the game. You guys figure it out. Get back to us when somebody's come up with a working solution.
Yeah, and NASA has been doing that with the NASA space apps in different ways, and I think that really engages the community to be able to contribute. And people even like start startups, they get jobs out of it. So it's just the kind of thing that really promotes outreach with the community. And what you said is really it's really true. Sometimes I see people that have thousands of hours in the game and they just seem to know everything there is to know about space engineering. Like every rocket engine, every rocket in history, they just know absolutely everything. And especially when you take all of these mods, they increase the realism so much that you have to think about all the small aspects that you never thought were necessary to make a rocket fly. Like there is this realism overhaul mod, and it has the realistic progression in the career mode. So you have to make the rockets in like with a historical standpoint. So one of the things that you have to do for one of the missions is to create a rocket that whose downrange is 3,000 kilometers. So basically, you have to make it fly, and it has to cover a distance of 3,000 kilometers on the ground. So in order to make that happen, that is actually really hard because once your rocket actually goes fast enough, and it's horizontal going up to space, eventually its engine stops working because the propellants start floating and they eventually will not go down anymore. So unless you have some kind of way of rotating it, so what's called spin stabilization, you have to like tilt the fins a little bit. Unless you have that, your propellants will float and it's not going to work. It's going to explode. So if you don't simulate this kind of thing, you might know everything there is to know about orbital mechanics, but you might not see problems like that showing up uh, if if you don't actually test it somehow.
Yeah. And so what do you think then would be the gap to turn really skilled Kerbal Space Program players into problem solvers, or I don't know, mission architecture designers?
Yeah, I've thought about that before, and I met one of these players here at Purdue, and he was a first year student in planetary science, had like thousands of hours in KSP, and he just seemed to know everything there is to know about everything KSP related or space related. And I asked him, "Wow, you're like you seem to know so much. Why didn't you become an aerospace engineer?" Right? And he said, "I'm bad at math." That was his answer. And I do think that there is just so much technical knowledge that goes into the details that you have to go through in your training as an engineer in school that makes it really hard for people to actually become space architects in the future. But that is not to say that it's impossible or all the areas are limited. Like there are some like amazing ways of contributing that do not involve you calculating differential equations about all the orbital mechanics, right? So I think that this kind of simulation game opens the door for people to contribute in different ways, and that's the kind of thing that I'm trying to promote here.
So let's say that a person wants to follow in your footsteps. You know, they've played Kerbal Space Program quite a bit. They've flown a bunch of missions, but now they want to mod it to make it more realistic. So what were the mods that you were recommending?
Yeah, so there is one called KRPC, or Kerbal Remote Procedure Call, and that was the main mod to be able to use that API that extracts the data from the game. And you can use a Python code, you can use different programming languages to extract that. And then there is Realism Overhaul, which is actually a collection of mods. So RO and a Real Solar System, they are a collection of many, many different mods that use real engines, like procedural tanks, which are ways of you to fine tune the geometry. And I think there are dozens of different mods in that collection. A few other ones that I also want to like give a shout out are Artemis Construction Kit and SEP, Starship Expansion Project, which are just two examples of mods that actually provide the design of systems that are being used by NASA in the Artemis program and SpaceX and the Starship specifically. So with these, you can also play around with some parts that people modded to make it more realistic and actually match the specifications of NASA's and SpaceX's vehicles. And you can even get some of the lunar landers, such as the Blue Moon that was designed by Blue Origin, or the Human Landing System by Lockheed Martin. And obviously, there's only enough, like so much data that you can get. So these people that created the mods are also somewhat limited, but it's a very good place to start if you're interested in getting an idea of what this mission with many different kinds of systems entails.
Now, Kerbal Space Program itself, the game, has had a bit of a troubled history recently with the they launched the version 2, and I think there were problems with the company, and we're kind of in this weird limbo right now. You can still play the game, but we're not getting regular updates and so on. There's another game, was it Kitten Space Program, that someone is developing? What are some, like, we've been talking mostly about Kerbal. Are there other games in this genre that you think do a good job of sort of filling that niche?
That's a good question. I don't think I have a good answer to that, of different games that could fill that niche. Like, honestly, I think that the pushback that people got from KSP2 was just the fact that KSP1 is so good, and they weren't really pleased with like the updates enough to actually buy that KSP2 as more powerful than KSP1, and there were probably some bugs as well. So yeah, I still think that KSP is the go-to for rocket engineering and space mission. Yeah.
But you haven't seen any alternatives that a person could, like, if a person had played Kerbal Space Program and now they wanted to try some other game.
There are flight simulators, mostly for aviation, that could also be interesting. So these could also be interesting options.
I mean, are there ideas in either the Artemis mission or maybe a potential architecture to Mars or other interesting missions that the simulations tell you, like, there's a chance, like, there's something interesting here, there's maybe a different way that we could architect some of these missions that people aren't necessarily thinking about?
Yeah, there is just so many options, right? So there is an entire body of literature that you have to go through to be able to like get some creative ideas. But I think that games as a whole is just kind of an untapped territory. People don't really give it enough credibility, and this can enhance the simulation, especially in the age of AI that we're seeing right now. So some of my core research, like the frameworks that I'm developing, are AI based. So using explainable AI, machine learning, to be able to create models on top of all of these mission architectures. So to create that, you can either do the simulations based on data that you collect manually, or you can try to use a facilitator, which would be using the games. So I think that in other areas, not only space, but also in aviation and in mechanical engineering, and like electrical engineering, you just see so much creativity that comes from the gamers, and these can be leveraged for real engineering.
I mean, I think about other games that I play. A good example of this is, like, I play Path of Exile, and that in Path of Exile, there's kind of like the meta. What is the kinds of builds that people run that are most effective, and the meta changes, and sometimes the meta changes even when the game hasn't changed, because some maniac has discovered some new aspect of the gameplay that allows these combinations, and then other people pick up that idea and they carry it forward and they keep moving on with it, and then eventually it's shown that it's a very effective way to play the game, and then other people pick that up, and then that becomes the thing. And when I before SpaceX, and before we saw the launch, the reusable rocketry of Falcon, like I think the meta was giant disposable rockets. And then SpaceX said, well, what if we reuse the booster? And until they proved it, people were like, that's not going to work,
Mm-hmm.
right? But I'm sure the math, the fundamentals, if you went back to first principles, it was theoretically possible. You just had to actually engineer the solution that was going to create that. And so when we think about the different architectures that go to the moon and and the ones that have been proposed to Mars, I think of that in gaming as like that's the meta that people have thought of so far, and they tend to follow the same path. But there are always these openings that can open up in the meta if people come up with a good idea. And so I wonder, are there new paradigms that people can open up in this exploration? I mean, there's so many pieces to work with that it feels like we're not exploring them all.
Yeah. My favorite video game is actually not KSP, and it's The Legend of Zelda Breath of the Wild. And I've seen so many gamers come up with intelligent and creative solutions. Like in its sequence, Tears of the Kingdom, the players can basically use magic to create engineering. So you can basically glue pieces together. You can like put some fans on top of create a sail, and people just make all kinds of things with that. They just put bombs on top of I don't know, like wooden blocks, and they just go everywhere with all of these engineering devices that they created in the game. So I think that that's just an example to see like how the gamer community is so so hungry for this kind of open exploration, and sandbox games in general, they allow people to do that. And I think that the whole idea of being able to take things from the game and using them without necessarily having the technical knowledge to actually knowing what are the models behind, what are the physics behind it, and just going ahead and like jumping and doing it, that's just something so powerful. And I think that we're going to see a very neat revolution in the next few years, especially with augmented reality and virtual reality, and all of the meta quest that people are proposing right now.
I know people are you mentioned that you're using AI to sort of as a layer in considering some of these options, and people have been using AI to like play Pokemon. Mm-hmm. I wonder how well AI could play Kerbal Space Program.
Yeah, that's one of the key questions for my research, actually. So you mentioned Pokemon. That's also one of my favorite games. And people have been using AI using a method called reinforcement learning. So basically, they put an AI agent to play the game for them, and that AI learns what to do and what not to do. And that was probably one of the most fascinating concepts that I've ever seen that merges AI and gaming. That kind of inspired me to take this research to the next level. So I've been trying to apply reinforcement learning for the design of rockets, and that's another project that I'm currently working on. More on that later, but right. That's just another
that's
one.
The next paper. Yeah.
Yes, that's the next paper, exactly.
Yeah. Awesome. Rodrigo, what are you obsessed with right now?
My obsession in space or anything?
Anything.
I am a Buddhist, actually. I am obsessed with Eastern philosophy and just spirituality. I think that a lot of things that we see in mental health nowadays are really concerning, from our addiction to technology, from all our presence online, our constant presence, and being able to actually center ourselves and be kind to every human being is a challenge amidst like all the work that we're doing, all the ambition, the state of politics in the world is just something so stressful for all of us on a day-to-day basis. So I meditate every day, and I'm also currently the president of the Buddhist Society at Purdue University. So that is one of my key obsessions. I've read so many books about it. Yeah.
Yeah, it's a tricky time. Like, I'm old, and I remember the before times before the internet would fracture and destroy our brains. And so, like a lot of people who are kind of my generation, we get nostalgic for this time, and we shut off the notifications on our phones, and we realize that you don't need to refresh Reddit, and you can just go out and touch grass and spend some time out in the sunshine. But there's a generation, my kids' generation, that they were raised in this. They're steeped in it. They don't know a way around it, and they're having a much harder time finding their way to a more peaceful balance with their technology. And and I will go like hang out with my son, and I'll be like, you should get a good night's sleep. Like, you feel like you don't need to, like, if you go to bed at a reasonable time, you can get up in the morning, you can play your game some more, but you got to be able to learn this balance. And they're starting to kind of detox on their technology. And so I think this is starting to happen. Like, we realize that we took a wrong turn in letting this technology into every nook and corner of our consciousness, and that we are the product that these companies are feasting upon, and that we're able to kind of bring that time back. And I think when I look at a person like you, you're working on all these projects, right? You're simulating you're using technology, but you're using this very intentional way that you're finding fulfilling and useful, and you're not just scrolling on TikTok. And so I think that all sounds perfect. So yeah.
Anything with moderation, I think. In Buddhism, there is this very clear middle way, which is not to be super attached to something, but also not to forget about things altogether. So I think this is really important to create balance in our lives, and actually take all of these tools that we have and use them in a meaningful way.
Very cool. Well, Rodrigo, thank you so much for taking the time to chat with me, and I look forward to future space missions designed on video games, Kerbal Space Program. That'll be really cool.
Thank you so much for the invitation. It's been great talking to you.
Awesome, man. All right, take care. I hope you enjoyed that conversation with Rodrigo Schmitt. I've got a longer version of this interview where Rodrigo and I talk about mission analogs for Mars, the moon, things like that, where we can try to create and simulate conditions that astronauts and explorers would experience on Mars here on Earth, and how these are going to play a larger and larger role in the future of space exploration. And so we've got that additional interview component over on Patreon. We call that the Interview Plus. And of course, it's completely free. You can just go access it right now. I'll put a link in the show notes. Now I'm going to give you some final thoughts and feedback. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrew M. Gross, Barry Lake Roofing, Brian Bodie, Caradwin, Chuck Hawkins, Commander Bieluk, Cy Nielsen, David Gilton, David Mounts, Dustin Cable, Evan Pro, Greg Feely, Hunt Schultz, Hudson Moore, Jay Graves, James Clark, Jeremy Madden, Jim Burke, Jordan Young, Marcel Smith, Michael Purcell, Modso, Paul Roebuck, Ren Kaidu, Robeck, Sean Sargent, Stephen Fowler Munley, Thomas Ilskadron, Vlad Shiplin, and Wolfgang Klotz, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. I get this question a lot from people about, like, how can they go from being a high school student, maybe someone who is starting to choose their major in university, how can you follow this path, your interest in working on actual space missions? You want to go and work for NASA or ESA or things like that, JAXA. And it's games like Kerbal Space Program where you are actually going and simulating the missions, understanding all the fundamentals, crank the complexity up, put in all those additional mods, learn to do the math, and you will have a much better understanding and framework for how missions function, all the different components, and even from a management perspective, so that when you actually do go and build in those skills from university and eventually apply for jobs at these rocket companies, you'll have a lot more experience. So Kerbal Space Program, who knew that it was a very good experience for you? All right, I hope you enjoyed this interview. We will see you next time.